testing of the CTAL in the pulmonary artery to left atrial configuration, which means that we attach the device via the pulmonary artery and then back to the left atrium of the heart. Our goals are to develop a compliant artificial lung with resistance lower than that of the native lung, which would also ultimately reduce the strain on the right ventricle of the heart. So as you can see, we have our pulmonary artery right here and our left atrium over here. First thing that happened was that a graft was placed, sewn to the pulmonary artery. The blood would then flow, once the device was attached, the blood would flow through the artificial device and back to a graft attached at the left atrium. The pulmonary artery to left atrial CTAL use will not decrease the cardiac output, and the PA banding only minimally increase the right ventricle workload with the CTAL in place. And finally, the resistance through the device did not increase at higher rates. All of these findings corresponded with our hypothesis, which was excellent and allowed us to move forward in the experiment. So, due to the success of the acute testing, we are currently testing the chronic PALA configuration. And normal adult sheep we've seen survive approximately 16 days. So hopefully in the future this time frame will be lengthened, and we can eventually attempt chronic CTAL use in pulmonary hypertensive sheep, which will basically simulate a person with lung failure, as opposed to using these sheep who are already completely healthy.
And when we look at differences in acoustic qualities of the signal, we find that it can actually hold information about the caller's age, gender, identity, and potentially hormones as well. So some studies in the past have shown this relationship between hormones and vocalizations. So meerkats make these alarm calls to warn their other meerkats in their community that a predator is approaching. And a study on these alarm calls shows a relationship between the acoustic qualities of their calls and the levels of stress hormones in the caller. Also, in primates, it was found that there's a relationship between acoustic qualities of Barbary macaques and females, fetal humans, between their calls and their reproductive hormone levels. So the qualities we looked at are duration, which is the length of the call. And on the spectrogram, you see that here on the x-axis. Also, we looked at the frequency. And this is how often the sound wave repeats itself. Essentially, this is just the pitch. So in a single call, we see all these horizontal black lines. And these each represent a different frequency in the call that the gelada is making. So the fundamental frequency here is this thickest black line. And that shows the main frequency that we heard. But another reason that geladas are so interesting is because they have so much complexity in each call. And each of their calls consists of all these different frequencies that come together to hear the single sound that we can hear. So to summarize these results, when we looked at stress, we found that there's potentially this correlation here between stress and duration and stress and frequency. But the data wasn't entirely convincing, so we're leaving this at possibly. In estrogen, we found no correlation between duration, but a strong correlation between estrogen and frequency. And lastly, when we looked at reproductive status, we found that this correlates to the call's duration and to the call's frequency. So could grunts be a signal for stress levels? As I mentioned, this is a possibility, but we would need to do more studies in this field. And one reason that these could correlate is that it might benefit a female to get attention from other females if she has a longer duration grunt. And that was the trend that we saw in our data. Also, in our study, we looked at primarily grunts. But if you remember what I played earlier, a lot of what geladas make are these whole sequences with grunts and inhaled grunts, and a lot more information could potentially be held in these whole sequences than just what grunts can tell us.
And specifically what I've been doing is a lot of work with how your lower extremities, specifically your knee, thigh, hip, lower leg, foot, and ankle are influenced in a motor vehicle crash. And what we have come to know is that age, gender, and body characteristics are three major components that affect injury in a crash. such as we have figured out that women tend to sustain more foot ankle injuries and men tend to sustain more hip, knee, thigh injuries. And we've also come to realize that the extremes of the population, such as female, obese, and older occupants, tend to run a higher risk of sustaining injury in a crash. And an understanding of these effects is necessary to improve vehicle safety for all occupants. So as you can see by this graph, the risk of sustaining an AIS 3+ injury, which is a serious injury such as a displaced fracture, increases significantly for both males and females as age increases. Landmarking is a process in which we take the bone and highlight different parts of the bone that are subject to vary among occupants that we need to take into consideration to apply to the population as a whole so that we don't just have the average of the population. And what landmarking does is each of these points will eventually return a set of coordinates, and these coordinates will then be placed into a statistical model that will run simulations in order to see how an occupant is injured in a crash without actually having to simulate a crash. And where we hope to go from here is, as soon as we have digitized all of the scans, we hope to take their data, which is in the form of coordinates, and apply them to a finite element model. And what a finite element model is, it is a mathematical representation of something. In our case, it's a human. And what we do is we break down the human body into very, very, very small pieces and analyze how each small piece is subject to stress and strain. And then we analyze how the whole body would be affected after analyzing each small piece to see how they're affected in stress and strain.